All right, so this is 1F, notes. So the top problem is notes, and then after that it's the classwork. For the classwork, just make sure to check your answers. So Jessica's school is selling tickets to the spring musical. On the first day of ticket sales, the school sold 7 senior citizen tickets and 10 child tickets for a total of $120. The school took $65 on the second day, took in $65 on the second day by selling 4 senior citizen tickets and 5 child tickets. What are the price of each senior citizen ticket and 1 child ticket? So all I really want us to do is to set these up. So our steps are separate the two equations within the problem. So we have a first day sales, and we sold 7 senior citizen tickets and 10 child tickets. On the second day, the school took in $65 by selling 4 senior citizen tickets and 5 child tickets. So the first thing we need to do is we need to, after that, so step 1 is done, we separated the problems. Step 2 is we need to assign the variables. So I'm going to have x and y. X I'm going to say is going to equal, we don't know, and the x and y always come from the price, so it's from the question what we're trying to solve. We're trying to figure out the price of the senior citizen ticket and child ticket. So x equals the cost of, I'm going to make this the senior citizen ticket, and y is going to be the cost of a child ticket. So we're going to write the equation. Oh, and by the way, x and y, it does not matter which one's which. You just have to define it. You have to set it right away. So you can switch the x and y around. With the x could be the cost of a child ticket, and y could be the cost of a senior citizen ticket. You just need to keep it that way. So we're going to do the first day. First day we sold 7 senior citizen tickets and 10 child tickets. So each ticket sold has got to be times the cost. So we need to be able to do 10, we have 7 senior citizen tickets, 7 times the cost of each senior citizen ticket, plus the 10 child tickets times the cost of each child ticket. And that's going to equal the total of $120. Now for the second day, we have 4 senior citizen tickets, so 4 were sold times however much the ticket was cost. The ticket costs plus, because we're adding these together to find out the total. So the total would be adding the 5 children tickets, so 5 times y, or 5y, and that equals $65. And there are 2 equations. This is already automatically set up into, if you really want to solve it, you'd solve it by elimination is the easiest because they're both in standard form. All right, let's look at number 1. So first, take a second and read it, pause and read. And now let's break this into 2 different equations. So our first sentence here is high school A. That's our first scenario. And our second scenario is high school B. Look at what it's, each van and each bus carries the same number of students. We don't know how many students are in each van and in the bus. So those are going to be our variables. So x is going to equal the number of students, and just because the vans are first, I'm going to put each van, and y is going to equal the number of students in each bus. So high school A, we're going to go with that one first. Has 14 vans, so 14 times however many people are in the van, so 14x, and we're going to add that to 10 different buses. 10 times y, so 10y equals 800. Next we have 8 x, so our next school, 8 vans, so it's 8 times x plus 2 times y equals 238. And if you want to find the number of students, so let's find the number of students. So I'm going to take, so that's my expectations is you set them up. Now, if we want to actually solve, I'm going to multiply the bottom equation by -5 to get the y terms to be opposite. So I have 14x plus 10y equals 800. And the bottom equation, when I multiply this -5 in, I get -40x minus 10y, so there's opposite coefficients on the y's, equals, that's at what, 1,200, nope, 1,100, and, oh my gosh, 5 times 238, sorry, now I gotta figure this out. 5 times 238, brain's not working today. 1,190, that's what I thought. Sometimes our brains just don't work the way we want them to every day. So when we add vertically, we get a -26x. Our y variables cancel, they eliminate. And we're gonna, that should be a negative. And then when you add those together, we get 390. So -26x equals 390. If you divide by -26, negative 390. 390 to 26. 390 and 26. $15. So we get x is going to equal 15. Does that make sense? Number of students in each van? Yep, 15. That sounds about right. Now I'm going to take from my original equation, I'm going to substitute in 15 for x. So 14 times 15. I need decimals for this again. 210. Oh, minus 210, sorry, minus 210, minus 210. I'm gonna get 590. Divide by 10. And we get the y is equal to, 59. What in the world kind of math is that? 59. So number of students in each bus, 59. Number of students in a van, 15. All right, number 2. Matt and Michaela, so read this problem and then we'll get to it in a minute. So pause, read, and then we'll come back. All right, so let's define see what our equations are. We have 2 different scenarios. We have, oh, I see, I misspelled that, should be Matt, not math. So Matt has 6 cherry pies, 8 pumpkin pies for a total of $280 or $220. Michaela, 12 cherry pies, 10 pumpkin pies. So let's define them first, define what we need. So we need to find the cost of each cherry and pumpkin pie. So x equals the cost of a cherry pie. Y is going to equal the cost of a pumpkin pie. So Matt, the first equation is going to be 6x plus 8y equals $220. Next one is 12x plus 10y equals $320. Find the cost of each cherry or pumpkin pie. So I'm going to do the exact same thing as I did up top in the last problem. I'm going to multiply, let's see, I'm going to multiply this top equation by -2. So we get -12x minus 16y equals -440. The bottom equation is 12x plus 10y equals 320. This one's going to be a little simpler. When we add vertically, We get a negative 6y equals a negative 120. So we get negative 6y equals a negative 120. That's going to equal 20. So pumpkin pie costs $20. Substitute that back into one of the original problems. So 6 times x plus 8 times 20 equals 220. I just chose the top one just because it looked like they were smaller numbers. No real reason. You'll get the same answer for either one. And $10 for a cherry pie. Again, my expectations here, all I need for the test, just the setup. That's where my expectations are. And last one, Leah and Amanda. So read the question and we'll come back. So pause right now, read the question and we'll come back. All right. Step 1. Define where the two equations are going to come from. They're going to come from, so both Leah's, so we got Leah, and we have Amanda. So Leah spent, we have cost of rose bushes, so my x is going to be the cost of a rose bush. Y is the cost of a geranium. System of equations, so we have Leah, we have 8x plus 1y equals, it cost $68. Cost for Amanda was 11x plus 8y equals 173. Now to find the cost, and again, this bonus, you don't need to do this. To find the cost, we got to think about what can we multiply by. I'm going to multiply this top equation by negative 8 because that's going to make my y's eliminate. So that's going to be negative 64x minus 8y, 8 times 68. 544. That's a negative. And then our bottom equation, the y's are opposite coefficients, so that's good. Line them up, add vertically, you got negative 53x equals 544.73. Oh, I think I did something wrong. I gotta add 173. Negative 371. Divided by negative 53. And we get 7. So the cost of a rose bush is $7. Well, that'd be nice. So each rose bush costs $7. Let's substitute it back into one of the original problems. I'll go to the top equation because, so 8 times x, replace the x, 1 times y is just y, and we got 56. Because there's no y coefficient on the y, that's why I chose that one. It does not matter which one you choose. So that's $12. $12 for a geranium and $7 for rosebush. Hopefully